Hey guys, here's a quick little video to help you with some of the calculator stuff. I know it's a little late, sorry, I just got back from conferences and nobody asked anything until now anyway, so here you go. Let's just put something ridiculous in there, some silly function that probably has no meaning whatsoever. Let's see, 6x cubed minus 37x squared plus 6x plus 88. So there's our original. Let's just do a regular, standard window and whatever. So what can you do with the calculator? Well, one of the things you're going to need to be able to do is to find the derivative at any particular point. So if I said find, if this was like position and I said find me the velocity at 2, you literally can go to your main screen, math, for me it's 8. I know some of your other calculators might be different, but look for the derivative and deriv, so math 8, put in your y1, so let's see, variables, y variables, y1, comma x, and then comma the value you want. So let's just say it's at 2, and it will literally tell you what the derivative is. Okay, so basically negative 70 meters per second, whatever it is. You could also do it from the graph. Do the same thing. Math 8. From the graph. How about the graph? Second, calculate, and then it is dy dx. Okay, so second, calculate, number 6, dy dx, and then now it's looking for what value do you want. So we want the value at 2. So just type in 2, enter, and you get the same thing. Alright, that's one thing you should be able to do. You should also be able to use your graph to find the, when the derivative is maybe 0 or something like that. So I don't want the roots of this function, I want the roots of the derivative. So actually, if I zoom fit this, get a better idea of what this picture looks like. Let's let that come into play here. Okay, so if I want when the derivative is 0, I'm guessing it must happen somewhere around, this is the original by the way, somewhere around here, and then it looks like it does it again somewhere around here. It's kind of hard to see that. So we want to look at the actual derivative. Remember, this is just y, not y prime. I could do this two ways. One, I could grind out the derivative, just a bunch of power rules, no big deal. But you should also be able to do this with the calculator. Just do the same thing, but do it into your actual y equation. So math 8, y1, assuming it's already in there, comma x, comma, the only difference here is instead of typing in a number, remember this is going to graph the value of this. If the value of this is, say, negative 70 like it was before, it's just going to graph a horizontal line. So I want to graph this for every x value that I put in the domain. So I do the same thing, n deriv, y1, comma x, so it does all the points. And when I go to graph it now it's going to graph this is the derivative of this. Oh, you know what, I should have changed, let me make it a thickness. Let's do that again. So there's the original. Here comes the derivative, still original, sorry, here comes the derivative, there it is. So remember we did these kind of pictures before where, okay, positive slope, eventually 0, okay, so positive and then 0, and then it's hard to see what it's really doing in here. We're going to probably want to zoom in on that, and then it looks like eventually it's positive again. So let's actually do that. Since we really only care where this is crossing, let's actually change our window to like, negative 2 to 2. And let's not even graph the original for a moment. Let's just graph the derivative. Okay? And let's see. Wait for it. There it is. Oh, that's not. It's all. Everything seems to be happening like right around here. So it's kind of hard to see what's happening there. So let's even zoom in more. Let's go from like negative 2 to maybe 6. Let's go negative 2 to 6. And you know what? The thickness isn't really helping now, so I'm going to go back to the original. And there it is. And let's see what it's doing. Sometimes you got to play around with the windows a little bit so it looks good. All right, something's definitely happening here. And then where's it going? Over here. So something's happening here and here. So I'm going to go ahead and find a 0. It's definitely happening around there. So it's definitely between negative 1 and 1. So between negative 1 and 1. And I'm going to guess, it looks like it's almost right around the origin. I don't think it actually is the origin, but it's right around there. And there it is. Okay, so your first root is 0.0827 whatever. Now remember, this is the derivative. So the derivative is 0 here. So that means that, if it asks you something about, the particle at rest or anything like that, you can get that from this graph. Same thing over here, whatever that value is. Second, calculate 0. It's somewhere between 3 and 5. 3 left bound, 5 right bound. Guess. It looks pretty close to 4. It's almost exactly 4. It's probably, okay, so 4.028. So the particle is at rest at 0.08 or whatever it was. Honestly, I forgot. And around 4.028. And you can answer that exact question just by typing in your derivative in here. So these are the kinds of things you need to be able to do with your calculator. Hopefully you've already practiced those, because again, nobody really asked anything until just now. But I can keep answering questions as long as you want. Okay. Good luck, and I'll talk to you guys later. Bye.